Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video, today we are going to look at the one sample t-test. So I'm going to explain how this is done, and then we're going to go live in JASP so you can see how I'm doing this. Now, again, what is the one sample t-test? Well, there are three different types of t-tests and a z-test. Here is my flow chart. You can either have one sample or two samples. For a one sample test, we have the z-test, and this is when you know the standard deviation of the population. So this is going to be rare. Again, this is something we did often when we were calculating by hand. But a one sample t-test, you do not know the population standard deviation. Now, what I'm doing with a one sample test is I'm comparing my sample to another known sample. So this would be the case that I'm giving my students a standardized exam, and I'm going to compare them to the national average. And by national average, I mean the national mean or arithmetic mean. In the two sample tests, we've got the paired and the independent samples t-test. This is where I've got either two classes or I've got a pre-test, post-test design. We will look at those in different videos. So right now we're looking at the one sample t-test where you do not know the population standard deviation. Okay, so with the one sample t-test, this is used to compare the mean of a sample to the mean of a population. So again, I want to compare the mean on the final exam of a course at URV to the mean of a final exam of the course across Catalonia to see if my students are performing similar to the general population. And this is a two-tailed test because I don't know which direction the difference will be. So I don't know if my students are going to be higher or lower. And so we would also need to know the mean of comparison. So I would need to know the mean on the test across Catalonia. So let's say if I knew that the students across Catalonia, the mean was around 70%, I need to know that to do this particular test. Okay, so what we would do is first we would put our data into an Excel file and convert it to a CSV file. Again, you have to have it as a CSV file or JASP will not read it. Open the file in JASP. Make sure the test scores are scale and not ordinal. And go to the t-test, click on one sample t-test, move the test scores into the variable, and the output generates, but it's not correct until you put in the mean score from the population in test value. Then we can observe the output, and if you want, you could look at the descriptives and the descriptive plots. Now, after this, you also need to get the effect size. So let's have a look at this. Here I've got the scores in an Excel file and I'm converting it to a CSV file here. I'm making sure that the file is scale. And then I'm going up to t-test and going to one sample t-test. Now here I would enter the arithmetic mean of the population we're comparing our students to. And I've got the output right here with the p-value. Okay, so here I've got descriptives where I can click on descriptives getting the mean of my students and then comparing it to the mean of the students in the general population. Okay, so if you can see here that the p-value is 0.278. So the mean of my students at 74.867% is not statistically different from the rest of the students in Catalonia. Now, to interpret the one samples t-test, the null hypothesis is that my students will score the same as the general population. The alternative hypothesis was that they would not. So the p-value is 0.278. Therefore, we reject the alternative hypothesis in favor of the null hypothesis. The groups are not different. My students are similar to the other students. And so the positive value for T shows that my students' scores are higher than the mean. If the score was negative 1.128, then my scores would be lower. So this is how we know this is a two-tailed test. And we need the descriptive statistics to do the write-up, and I'm going to show how to do the write-up in another video. But we're also going to have to look at the effect size. So remember, for Cohen's d, we would need to know the effect size. And it's 0.2, 0.5, or 0.8 for small, medium, large. So now let's go live into JASP. And I'm going to stop sharing this screen and I'm going to share JASP, and we'll pull up a data set and see how this works. So I've got JASP open here. I'm going to the main menu, going to computer. I've got this file saved on my desktop, and we've got the CSV file here. We're going to open this. The participants, this is nominal. The final exam, this is scale. And so we're going to go to t-test, and we're going to go to one sample t-test. I'm going to take my final exam and move it over here. Now, notice here that there is an option for the z-test under one sample t-test, but you need to know the standard deviation. So if I click on this, I would need to know what the standard deviation is. I don't know that offhand, but let's say as an example, the average score or the arithmetic mean for the national average on this exam is 62. Now, I'm going to go to descriptives. I can see that the mean for my students is 71. And so we've got a positive number here telling me that my students scored higher, and a p-value of 0.007. That tells me that this is significant, but we also need to get the effect size. So the effect size with Cohen's d is 0.5. So this gives me a medium effect size. Now we can also go to descriptive plots, and we'll just get a plot of what my students look like. So this would be from the low to the high. Now let's say that the test value here, the mean score for the national average was 88. So of course I know my students are 71. This is where you're going to see the negative t-value. So now I know my students scored lower than the national average. This again is significant, but you're going to see a negative Cohen's d, and now we've got a high effect. So this is where the test value is really going to change how you're comparing the students' performance. So we can see the negative where my students are performing lower. Okay, so this concludes the one sample t-test. And thank you so much for watching this video. I look forward to seeing you in the next video.